Hello everyone, my name is Ram. Today I'm gonna talk through module number 4, risk and quality management for team number 6, thermal hard hat project. So as a general overview for this presentation, I'm gonna walk you through some of the updates we have made on this module, which was not introduced on our previous ones, and I'm going to talk to some of the key project risk quality issues and define the quality management plans built for this project. So I'm going to start off with the slide number 2, scope and structural updates. So since the last time we met, we have updated 3 things on our project scope. The first one is market and business case, where we have introduced the overhead as an indirect cost and its impact on the project. We have the post-delivery support, which talks about some of the support we need to provide to our customer as a part of our quality feedback loop, right? And also making sure we are providing the support they needed as a part of the warranty claims, and which also help us to gather constructive feedbacks and build a good relationship with the customers. And the third one is the updates on the code for thermal sensor and lithium ion battery, which help us to establish certainty of our project budget by 8%. So I'm going to go through some of them in details on the upcoming slides. On the slide number 3, we discuss about the overhead refinements. We introduced the 12% overhead in our project as a indirect cost, which includes the cost such as administrative cost, utilities, right, the software licensing, and some basic management of the office supplies and stuff like that. So eventually it's gonna increase the overall total project cost, but I think this is good to have because it helps us for the better transparency of our project cost, and also help us to understand like create a good standard cost for our product, which reflects direct material, direct labor, and the indirect cost of the overhead. So this is good to have for the better visibility of our project as well. On the slide number 4, we want to talk about some of the updates on the schedule we have made for the quality improvement effort. So for example, we're trying to optimize the test time for the framework and the integration part, so that we can test out some of the worst case scenario. And we also wanted to review some of our DFMEA, right, which help us to build a good quality product from end to end, from basic RCLP process all the way down to the product launch and shipping out to the customers and providing them the warranty claims, right, these kind of things. So these are the updates we wanted to make on our schedule, and also these kind of efforts help us to reduce the time of the rework and also limits the delay on our project. So these are some of the things that we wanted to introduce there. So as a part of the risk identification for our project, we have categorized them into 4 major buckets. The first one is the technical risk, second one is the financial risk, the third one is the schedule, and the last one is the operational one. So I'm going to go through each of them in details on the upcoming slide. Number 6, the technical and financial risk. So the technical and financial risk, in this technical side, we have the risk of sensor calibration issues, where we might be getting the wrong readings because of the lack of calibration on our sensors, and doesn't match our spec values, right? So again, this is a major issue because we might fail the whole project if that happens. So we wanted to make sure that this doesn't happen, so we need to address that by doing more calibration on our sensors, and also try to build a good integrated system, right? The second one is the framework communication issue, where the uh, we might see an issue, the microcontroller is not communicating with the thermal sensor. So this is also a potential failure mode for us. So in order to prevent that, we wanted to extend our time on the testing, try to integrate our both the hardware and the sensors properly, and making sure they are being tested on the worst case scenario and in the failure mode. And the uh, um, third one is the component price fluctuation. So I think that's something we don't have a heavy control on, right? Because of all these uh, global tariff situations and geopolitical things, that is likely to happen. So as a mitigations, we wanted to have a backup supplier. So if one of the supplier ran out of the business, we can rely on the second one. Also do like a bulk purchasing that help us to secure items on the stock if we need them in the near future, right? And the other one is the labor cost escalation for the project. Yeah, also in order to tackle that, we are trying to do a balancing staffing and flexible scheduling to uh, get in order to prevent that in order to prevent the kind of failure it might bring into the project. uh, Likewise, we have some of the schedule and operational risk. For example, on the schedule side, because of the long lead items on some of the major components like the thermal sensor and the filaments, it might delay the whole project, right? So we wanted to make sure that doesn't happen. So we wanted to make sure we have a good understanding of the supplier and the sorry. We wanted to make sure that we will benchmark our suppliers and reduce some uncertainties on our raw materials, right? On the second side, on the second one, on the operational side, we might run into the issues like not having a compliance with the safety standards, or like a lack of communication between the cross-functional team, where we might fail on some of our design aspect. And also working on silos might impact the project. So these are the operational risk I see on our project, we see as a team in the project, right? So in order to reduce all this kind of risk, we have identified some of the quality management plans on the later slides, which I'm going to talk through. On the slide number 8, we have the general overview of all these issues I just talked about, like, and rank them based off the impact it might bring into the project. So the technical and financial risk are the ones that might make or break this project. So it has a heavy impact on our project, whereas overhead and supplier benchmarking help us to reduce some uncertainties in our project, and making sure we have a stable, streamlined project execution from RCLP process all the way down to the executions, launch, and the warranty claim process. So we also have discussed that preventive testing protocol, or like testing on some extreme conditions, helps to minimize the reworks and ensuring a high quality product for our customers, and it also help us to build a good relationship, right? And we also identified the continuous improvement loop from the constructive feedbacks from our suppliers and from our cross-functional team, helps to ensure the entire life cycle of our product is really at a high standards. So we identified some of the risk, like we have done some of the risk analysis from our team. So we have two categories of that: the qualitative and the quantitative. The qualitative talks about high, medium, and low impact, whereas quantitative talks through the range of 1 to 5, where 1 being a minimal impact and 5 being the critical impact, right? As we categorize our issues, risk on based on these methods, we have identified that Sensor calibration and component cost has a major probability of happening on our project, and it has a huge impact, either make or break kind of things, right? Whereas framework communication, labor cost estimation, supplier delays, and prototype rework have a medium impact on our project based on our analysis here. As And I want to continue here on slide number 10. We have discussed some of the sensitivity analysis for the project, like the worst case scenarios and how we wanted to visualize the amount of impact it can bring into the project. For example, the 20% labor cost increase might increase the total overall cost of the project by 7 to 8%, whereas the 10% component cost might reduce the overall net profit down by 15% in total. So these are some of our risk analysis we have done as a team. So as we identified some of our major risks here, we have also discovered some of the methods for handling and mitigations those issues. As per our class discussion and our contents of the class, there are 4 major pillars, right? Like avoidance, mitigations, transfer, and acceptance, which I'm going to go through each of them in our upcoming slide here. So for example, for the technical failures, this falls under the mitigations, right? Like the sensor calibration issues, firmware failures, these are under mitigations, and we can prevent them if we have a robust design system, QA and quality assurance inspections, right? And making sure we test our prototype on the extreme cases so that we can justify our design is to an optimum level, and our integration of the system is well advanced for our customers, right? The financial risk like the component price and the labor cost comes on the transfer and the mitigations. In order to prevent those things, for the component price, we gotta make sure we keep eye on the alternative suppliers and try to maintain a good relationship with the suppliers and do a timely review of the suppliers that help us to ensure we are getting the raw materials in the decent price and within the good time, not having the long lead time, right? And for the labor cost, we need to make sure we have a close eye on the labor market tracking, and also some extensive training for our cross-functional team. That way we can support various activities within the team. For the schedule risk, like the supply delays, we gotta make sure, again, monitor the long lead times and try to find alternative solutions, and purchase some of the items in bulk so that we can have them on the stock. As the schedule on the schedule risks, we have the testing rework. In order to make sure we do our project on well-defined time, we gotta make sure we don't spend too much time on reworks and doing multiple things repetitively. So we gotta make sure we have the strict testing protocols to prevent that. And the operational side, we gotta make sure our product is up to date with the safety compliance, and we don't have any risk on that side, and making sure we all cross-functional team work as a one team and communicate well to resolve any kind of issues out there. On the slide number 12, I'm going to talk to the quality management strategy. So as a quality management strategy, we have introduced some of the frameworks like ISO 9001 or Six Sigma process, or like the Kaizen events to prevent various kinds of risks to prevent some of the risk we have identified before, and making sure we deliver the quality products to our customers, right? Uh, so that might be for reliability and compliance. We can do a cross-functional team engagement, work through the ECN processes, DFIMA file, PPAP processes, and we got to make sure we have a continuous improvement culture within the team, have a quality feedback loop from our customers, so that we can drive the constructive actions, and quality should be one of the major metrics for the product line, not just the cost and volume, right? So quality should be one of the major things for us. So, and there are some of the well-established improvement, lean improvement methods like PDCA cycle and corrective actions, which we wanted to implement on our project. Jumping into the quality metrics, these are some of the metrics we have defined for our product to be considered as safe and good product for our customers. For example, the sensor accuracy should be within plus and minus 2 degrees Celsius, within 25 to 50 degrees Celsius range. For the defect rate, it should be less than 1% on the production line. For the reliability, it should last more than 5,000 hours continuous operations, right? And the customer satisfaction have to be more than 90%, and the cost of quality should be less than 5% of the total project labor cost. So those are some of the matrices we have defined as a team. All right. So in order to do all these kind of improvement activities, we definitely need to have some quality data, right? So in order to do that, we're going to rely on some of the tools like the Kaizen events, where we're going to collect a lot of the feedbacks from our customers. We're going to do the Pareto chart, and making sure we have enough customer noise to make sure we implement the corrective actions on those ones. And there is a continuous improvement process of PDCA, which stands for plan, do, check, and act. So we plan everything from our basic RCLP process, all the way from concept technical design review. And the do section, we're gonna do a lot of testings and try to validate the performance of our product, right? And the check portion of that module, we're gonna compare results with the charts, the industry standards, and the act, we're gonna implement those findings and making sure we have a robust ecosystem built for our product, right? So these are some of the key components that we will be looking into to improve the product quality and have a robust quality improvement system in place for our product. And on the last conclusion slide, we are talking about how we have come with all these solutions and enhancement that we wanted to introduce on our project, right? For example, enable financial accuracy and lifecycle accountability once we do the cost modeling and the post delivery support, right? And the structural risk analysis and mitigation strategies will help us to reduce exposure to the critical technology failures, financial risk, and maintain the well-structured schedule for our project. And some of the quality and improvement processes like and the standards like ISO 9001, Six Sigma, and PDCA frameworks help us to do a continuous improvement on our product and maintain the standard out there in the market, and help us stand out against our competitors, right? And this the last one is the system reliability. So the proactive calibration approach, supplier diversifications and various quality assurance processes, and working on the constructive feedback from our customers will help us to be more scalable, compliant, and customer focused system in this market and be succeed in our project. Thank you.